Welcome. We are going to look at another concept from economics which can be expressed in terms of derivatives, that is a rate of change. This time it is from macroeconomics. If you have a nation or a region and you want to look at overall, when the income goes up, what fraction is saved and what fraction of the increased income is used for immediate expenses, that is used immediately. So if you take the total income of everyone in the nation or the region, state, whatever the big economic entity is, then the fraction of the income that's used immediately for expenses is called the consumption function, and amount that's saved for future expenses is called the savings. So if the income goes up by 1 unit, then a certain fraction will be used for immediate expenses, the rest is saved for future expenses. These are called the marginal propensity to consume and the marginal propensity to save. So these are rates of change of consumption and savings with respect to income. So in mathematical economics, they are defined as the rates dC over di and ds over di, where c and s are the consumption and savings functions. Since consumption and savings should add up to the total income, that is to say C plus S equals I, we see that the marginal propensity to consume plus the marginal propensity to save must be equal to 1. It is whatever is not used immediately is saved for future expenses. Again, as the kind of problems we'll be doing, the consumptions and savings are given as functions of I, usually just one of them because the other can be derived immediately if necessary, and we are asked for the savings and consumptions. If we are given the consumption function and asked for the marginal propensity to save, we can find the marginal propensity to consume, subtract it from 1 to find the marginal propensity to save, rather than to find the savings function and then differentiate, although it's not that much harder. So let's look at a simple example here. The consumption function is given as 20 radical I plus 0.5 radical I cubed minus 0.4 I divided by the quantity square root of I plus 5. We won't worry about units except for the fact that C and I and S are all typically expressed in the same unit, which means that dC over di and ds over di are dimensionless numbers. They have no units, which is what we should have expected from the definition because they're expressed as fractions. If you want them as percentages, you just multiply by 100. We will simply express them as fractions. So, since the consumption function is given, I will find the marginal propensity to consume first. We will write all the square roots in terms of fractional powers so that I can apply the power rule. Square root of I is I power 1/2, square root of I cubed is I power 3/2, and I'm going to use the quotient rule. The numerator's derivative is 20 times 1/2 I to the power 1/2 minus 1. 20 times 1/2 is 10, and 1/2 minus 1 is negative 1/2. That's how I get this I to the negative 1/2. And then derivative of I to the 3/2 is 3/2 I to the 1/2. 3/2 minus 1 is 1/2. Derivative of 0.4 I is 0.4. The denominator is I to the 1/2 plus 5 minus the original numerator times derivative of the denominator, which will be 1/2 I to the negative 1/2 plus 0. I just left out the plus 0, divided by square of the original denominator. Now we need to plug in the given value of I in this. It's somewhat long calculation. It's best done by just plugging things into your calculator. If I did everything right, it comes out to be 0.4716. So the marginal propensity to save will be 1 minus 0.4716, which is 0.5284. This concludes our look at the quotient rule, and I will stop here.